This is the mental flop extreme. Even though it might look like a weirdly proportioned floppy cube from this angle, internally this is actually a 2x2x3. But before we get into that, let's talk about how this is more or less the culmination of some earlier concepts. You might have seen this on my channel before. This is the Junior Mental Flop Extreme, and this is actually just a fully functional 2x2 with added turns on the end here. But you can see that this is kind of one of the faces of the 2x2, and then it turns like this and keeps going like this pretty much. It's just a 2x2 with added extra parts that turn like this. So this was inspired by Greg's Junior Mental Flop, which was just the 2x2 mod without the additional cuts here. And likewise, this Mental Flop Extreme is inspired by the Mental Flop, also by Greg, but again, that one didn't have these turns here. I'm told by the Twisty Puzzles Museum that this was actually invented before Greg by Ale Hladzilin. I tried. But this version is original, where you can actually make this fully functional floppy cube style scramble. But before I talk about how I designed and built the Mental Flop Extreme, I first want to talk about why it's conceptually possible. So on a regular floppy cube, this part and this part are identical, as are these corners, right? And that makes sense because they serve the same purpose. But the thing is, think about what these pieces actually do on a floppy cube. They just turn around in place. There's no way you can switch these pieces around. And because there's no way you can switch these pieces around, that means they don't have to be interchangeable, which means they can be completely different. I imagine that for ease of design and manufacturing on most floppy cubes, these parts will be identical, even though they need to be. But this isn't a floppy cube because I couldn't find mine in this moment, and this only applies to puzzles where parts are non-interchangeable. For example, here, these parts have to be the same because you actually can interchange them. It's quite a long algorithm, so I'm not going to do it for you, but yeah. And this, likewise, this part and this part, they're interchangeable, so yeah. But on a floppy cube, well, you could go ham, honestly. So on this side, the edge part is made up of just the top layer of a 2x2x3, and on this side, it's made up of just this part that's completely external to the 2x2x3. This concept of non-interchangeable pieces being completely different is applicable on a puzzle a lot of you probably have seen a lot more. This would be the Scube. You'll actually notice that no matter how hard you try, you can't get these two pieces to interchange. If you can put them next to each other, you can't interchange them. There's Braden's Weird Scube, which you can actually do that, but that's a completely different mechanism. And these parts, you can't put next to each other, no matter how hard you try, right? There'll always be kind of a center away from each other, or more. And the concept of these pieces being non-interchangeable actually manifests itself because these pieces mechanically are completely different. This one is actually more of a center, where this is screwed into the core and these parts move around it. Whereas this part isn't screwed into the core, this is just a corner and it moves around all the other parts. So that's kind of a more relatable example of what I'm talking about, and it's realistically not something that I think most people would have thought about, but it's just an interesting quirk about designing puzzles. Just bear in mind that not every piece that you think might need to be the same as every other piece might actually need to be that way. And especially in something like a floppy cube, you can definitely bend the rules a bit. So let's talk about how I went as to designing this puzzle. Essentially, I designed it in a modular fashion, or like a nesting doll type of mechanism. So first, I designed a 19 by 19 by 19 millimeter 2x2x1, exactly the size of a standard 3x3 cubie. I was gonna sticker this, as you can see by the sanded faces, but I never got around to it. And yeah, it turns pretty well, honestly, considering how small this is. So, in the modular fashion, I took this mechanism and added more to it, and made this 2x2x3, which is 19 by 19 by 57 now. So this mechanism is now here in the middle, but then you have these additional layers on top and bottom. This turns okay. It's a bit looser than the 2x2x1, but still definitely playable. And if I were to sticker this up, this would be a totally solvable puzzle. And then in the modular fashion even more, this is basically this 2x2x3, but turned by 45 degrees, and the main addition is these extra layers here. Now, in the process of designing this, I had to make some compromises. For example, you'll see that it's not actually proportional. I was trying with these puzzles' compactness here to make it possible to be fully proportional. And it might still be, but when I was designing this back in I don't remember, when was this, April? I couldn't get it figured out. And the other thing I really didn't like was these cutouts here. You can see that there's just triangular shapes on all of the cuts here that kind of take away from just material from the cube. And if you're a puzzle designer, it'll be immediately obvious why this is. It's because if anything was there, it would block a turn. So for example, this type of turn takes up this plane. So everything on this plane has to be clear. But then this turn takes up this diagonal plane, so everything has to be clear there as well. So you can see that, for example, if something was there, this would not be possible. And in fact, that's actually why I couldn't implement into this prototype a mechanism to turn this like that, because this cutout doesn't exist in this scenario. But yeah, all this to say, I couldn't get this proportional back when I designed it. I'm pretty sure it's possible, and if I were to try it again, I'd definitely go for that, but that's not the biggest issue that this puzzle has. The turning is a bit, not great. Like, for example, see how loose this is? I'll talk about this in greater depth later, so for now, let's take it outside and just go over how it turns. While I definitely think this was a worthwhile proof of concept to create, in the end I'm not really satisfied with how this iteration of the mental flop extreme looks or with how it turns. Aesthetically, I really don't like how unproportional it is. And then the turning quality is genuinely all over the place. One of the vertical turns is really good, the other's too loose, and then the top and bottom layers are too loose and also difficult to turn. At least the Floppy Cube's left and right layers work pretty well. I believe that my approach of nested mechanisms does work well in certain applications, but this is not a good example. So if I were to remake this, I would try and consider the mechanism as a whole, rather than basing it off of a 19 by 19 by 57 millimeter 2x2x3. The purpose of that was to make the entire puzzle proportional, but even that didn't work out. I will say though, having solved it a few times, the mental flop extreme is surprisingly interesting to solve, so I'm at least happy about that. Let's go ahead and scramble it. I've already solved the mental flop extreme a few times, and genuinely this is a very interesting puzzle. Just the fact that you can get this middle section solved, and then you can have a 1x3x3 floppy cube setup that is unsolvable, is really interesting, and it honestly makes this puzzle much better compared to what I was expecting, which is you just solve the middle section, and then you can just kind of solve the floppy cube using regular tactics. So the fact that that's not always the case makes this a much more interesting puzzle in my opinion. But anyway, as I just said, let's try solving this central tower first, the 2x2x3. Okay, so the top and bottom layers are solved, and then of course solving the central layer is just like solving the central layer of a 2x2x3. And I would say that the central layer is now solved. I haven't paid attention much to these outer two layers at all. I've just been kind of looking at the parts that comprise this column, which means all these colors and all this stuff is done, but I haven't put much thought into how these parts relate to these. So let's start doing that and try and see if we have a solvable combination just by using floppy cube moves. So it actually might be the case that it is solvable, because I believe if I were to just do this little algorithm that does work on a regular floppy cube, oh, okay, never mind. So, of course, at the last second I didn't notice that this part and this part needs to be swapped. I don't think, that's definitely not possible to occur on a regular floppy cube, so I'm gonna have to think a bit outside the box on what I'm gonna do about this. I don't even know if there's anything I can do other than swapping this set of 4 pieces with this set of 4 pieces, right? Because if we go here, the color scheme is supposed to be red, white, blue, but this is green. So in theory, I could have paid attention to this from the start, but this is really not a puzzle that takes a while to solve, so I might as well do it in the most interesting way possible. So yeah, I guess I have to swap around the entire top and bottom layers. That sounds fun. Alright, we are finally back in a cubic shape with all of the parts swapped. So now if we look at this more closely, we have red, white, and blue clockwise. That is the normal color scheme of a cube, so at least that's correct. Now let's see if we are actually going to be even able to solve the floppy cube now, because there's a hot chance that even now the floppy cube is still unsolvable. As it turns out, this time it actually was solvable. Okay, so I'm glad that it didn't at the last second pull out something. Either way, for a surprisingly simple concept, this is a incredibly fun puzzle. I just wish it turned a little better, because as you've probably been noticing, it's been kind of a struggle to get this thing to work properly. These turns are awful. I really have to squeeze it in to get it to turn properly. This turn is way too loose, and this turn is just normal, and these turns are normal. The reason why this vertical turn is so loose and unsatisfying is because the screw in the inner 2x2x3 goes this way. So that means that this has proper tension on it. But this is kind of just relying on the tolerance of the pieces, which actually, on the prototypes I had, I'm not sure which is which, one of these was the good prototype. Okay, no, this was the good prototype that I based this on. So yeah, in this prototype, it's actually fine. Like, both of the axes work well because there's no external pressure on the puzzle. But here, where you have all this added bulk of these parts, and on top of that, you kind of have this extra mechanism for these outer parts here as well to be able to turn around here. That all just adds a lot of extra bulk and makes the puzzle less stable. I think the biggest flaw of this design is the fact that I essentially designed a fully functional 2x2x3 mechanism, and then essentially added stuff on top of this to have more parts that hook into these, which essentially meant that there's now 2 layers of mechanism that this turn has to achieve, and that really makes for terrible turning. So yeah, a lot of lessons learned with this puzzle. If I were to redo it, I'd also try and make it proportional. I'm sure you understand how geometrically these diagonals need to be kept unoccupied, and also that this axis needs to be kept unoccupied, which is why there's these awkward right triangles of just nothing. But if I were to redesign this, maybe I'd try and fiddle around with the size of things to make it look a little better. But of course, in its current state, I'm not selling this puzzle. Thank you all very much for watching. I really appreciate it. I'll see you all next time.